This is a vial full of aerogel. You can see it's a very light blue, kind of hazy looking substance. It actually has the nickname Frozen Smoke. And it's very, very light. It looks about as light as it is, maybe even a little bit heavier. So each of these pieces weighs less than 100 milligrams, which is a very, very low weight considering their size. It actually is less than styrofoam. And the way you make aerogel is you use something called a sol gel. Now, a sol gel is a cross-linked network of a backbone, and then you have some kind of liquid in its pores. So in the case of these aerogels, you have a silicon dioxide backbone, that's just quartz or glass, and inside the pores you have air. But before you can get air inside the pores, you need to have a liquid as kind of the precursor. So the way that you do that is you use two chemicals. There's ethanol and a chemical called tetraethyl orthosilicate in these vials. And this one contains ethanol and tetraethyl orthosilicate, and this one contains ethanol and catalyst along with a very, very small amount of water. So what happens when we mix the two is that there's going to be a reaction between the tetraethyl orthosilicate, or TEOS, and the water. And the TEOS is going to react with the water to create a silanol group. A silanol group is very reactive, so it wants to bond with another silanol group, which wants to bond with another silanol group, and so on and so forth. And what you end up with is a macroscopic network of silanol-silanol bridges, which we call a siloxane bridge. That all probably doesn't mean very much to you, but hopefully you'll be able to see when I mix these two chemicals together, there's going to be a reaction where it forms a gel. So as you can see, these are both very liquid solutions in these vessels. What I'm going to do is I'm going to pour them both into the same petri dish, and they're going to react with each other to form an alkagel. That's a gel with alcohol in its pores. So we're going to pour it in, and if we're lucky, it's going to happen very, very quickly. If we're not lucky, it may take a few minutes, and we'll come back to look at it. Gel is now finished, and to prove to you that it is no longer a liquid, I can actually turn it completely upside down and it stays in place. So this could now be turned into an aerogel if I processed it correctly, just like these. What is very interesting about this particular gel is that even though it is in fact a gel, doesn't come out of its container, the kind of different thing about this is it's not squishy like a Jell-O or some other kind of gel, something that you might associate with that word. In fact, it's very, very brittle. You can see touching it produces a crack. So that's a very important distinction with sol gels versus some other kinds of gels. Although they are from the same root word, what ends up happening is they are very, very brittle.